Hello, am I audible? Can you hear me? Hello, hello, am I audible? Daya, are you there? Netra, am I audible? Are you there? Can you please
Yes,
confirm?
sir.
All right, are there more to come? Are there more students?
I'm not sure, sir.
All right, we'll wait for 2 more minutes and we'll start. What topic do we have to start today? Netra, is it Newton's laws of motion?
Sir, Raghav sir said we'll be doing problems
Related to NLM, right?
related to electromagnetic induction.
Okay, electromagnetic induction, sorry. All right, okay, 2 more minutes and we'll be starting it. Okay, so let us start. I think only these two students will come for today's class. Electromagnetic induction. We'll be doing some numericals related to that, and I need some participation from your side too. Please try to participate. Electromagnetic induction. Okay. So electromagnetic induction, the basics starts with the Lenz's law and the flux and the EMF that has been produced by the rate of change of flux, right? All right. The first question I'll be giving to you. Question says that a coil with an average dia that is 0.02 meter is placed perpendicular to the magnetic field. Placed perpendicular to the magnetic field of 6,000 Tesla. Okay. If induced EMF is 11 volts. Okay. And in that case, the magnetic field has been changed to 4,000 volt, 4,000 Tesla, sorry, and in 4 seconds. This happens in 4 seconds. So to find the number of turns in the coil, what is the number of turns in the coil? Try to solve this. Try to find the number of turns in the coil. I'll be giving you 3 minutes for each question to solve. Do not solve it. And please try to solve. Do whatever you can, whatever you think. And then I will let you know that whether that is right or wrong. That's how you'll understand and you'll learn. Hello, Namrata, are you there?
Yes, sir.
All right. So we are discussing the questions related to electromagnetic induction. This is the first question related to this chapter. Try to solve this, and if you could not, then I'll be solving it at the end. But try to apply your brain, whatever you have learned till now.
Okay, sir.
Netra, Laya, are you solving?
Yes, sir.
All right. Hello, Tabia, are you there? Can you hear me?
Yes, sir.
All right. Solve this question. 1 more minute I'll wait and then we'll discuss the answers. All right. Shall I solve it? Any answers by now? Shall I solve it?
Yes, sir.
All right. See here. So basically, what you have to do here, we know that the EMF produced is the rate of change of flux. So we can write it as minus n times phi 2 minus phi 1 upon t, right? So, yes, if we just talk about the value of EMF, that is the mod value, so we can neglect that negative sign. It is n phi 2 minus phi 1 upon t. Agree? Now, what is phi? Phi is magnetic field into area. And here, what is the value that is changing? That is magnetic field is changing. Area is not changing because you can see here that magnetic field got reduced from 6,000 to 4,000 Tesla in 4 seconds. So I can write the same thing as n into area V2 minus V1 upon T because this is what is changing there, right? Now area has been given to me. Area is pi r square. Radius is given 0.02 meters. So from there, if you put the values, every values, if you put it here, you'll get this. So EMF will be equals to, or EMF value is also given, that is 11 volts in the question. So 11 volts is equals to N into 22 pi into 0.02 R square into V2, that is 6,000, changed to 4,000 upon time, that is 4 seconds. From there you find N. So if you solve this, you'll get the value of N as uh, 11 into 7 into 4 divided by 22 into 0.02 whole square into 2000. Okay, so this goes and it will be around how much if we calculate this? It will be 4 upon 2 into 2 into 10 to the power minus 4 into 2000. These two gets cancelled. So 1 by, sorry, into 7 will also be there. 7 by 0.2 or 35 will be the answer. Got it?
Yes.
Did you understand it? Everyone? This question? Namrata, did you understand it?
Yes, sir.
All right. Next question. Find the field, magnetic flux linked with a rectangular coil of size 6 centimeter 6 centimeter into 8 centimeter placed at right angle placed at right angle to a magnetic field to a magnetic field mm, of 0.5 Weber per meter square. Try to solve this. This is easy. Do it fast. Do it fast. It is easy.
Sir, I got it as 2.4 into 10 to the power minus 3.
2.4 into 10 to the power
Minus 3.
minus 3 Weber. That's correct. Very good. Anybody else?
Sir, 24 into 10 to the power minus 4.
Yeah, same thing. Same thing. Correct. 24 into 10 to the power minus 2 or 2.4 to the power minus 3. Same thing. Okay, you're getting it. Good. So it's easy. Flux is equals to B into A into cos of theta. Right? So if they are aligned, so it will be theta will be 0. How it will be 0? Because this is the rectangular portion, and if it is perpendicular, crossing perpendicular to the area, so area vector will be at 0 degree to the, this is area vector. Area vector is always perpendicular to the area, and this is the magnetic field. So magnetic field and area vector are at 0 degree angle. So cos 0 is 1, so it will be B into A only, and that will give you 0.5 into 6 into 8 divided by 100 into 100. Correct. Good. All right. Next question. Next question says that a square of 600 turns, each side, 20 centimeter, is placed with is placed with its plane inclined at 30 degree to a uniform magnetic field of 4.5 into 10 to the power minus 4 Weber per meter square. You have to find the flux through the coil. Find the flux through the coil. Try to solve this. Hello, we have new participants here. Darshini, right? Am I audible, Darshini?
Yes, sir.
All right. So we are solving questions on electromagnetic induction. Try to solve these questions. If you're not able to solve this, we'll be solving at the end together. Okay? But try to solve it.
Okay, sir.
Is it 5.4 into 10 to the power minus
5.4 10 to the power minus?
3?
That's correct. Good. Anybody else with the same answer? Divya? 5.4 10 to the power minus 3? Namrata? Netra?
Yes, sir.
Same answer?
Yes, sir.
All right. So here we have to find the flux. Flux is nothing but NBA cos of theta. Okay. The thing is that here we have been given a square loop and the flux is passing by at an angle, but that angle is given with the area, that is 30 degrees. But we need to find the angle with the area vector. Area vector is perpendicular to the area. So from here, this angle will be 60 degrees. So this is what our theta will be. This is magnetic field. They are given inclined at 30 degree to the uniform magnetic field. So magnetic field is inclined to the area at 30 degrees, but we need to find the angle from the area vector. Area vector is perpendicular to the area. Okay. So this theta will be 60 degrees. That is the trick here. So N is given 600 turns. Magnetic field is given 4.5 into 10 to the power minus 4. And area is given, 20 centimeters. So 20 into 20 by 100 into 100 to convert it into SI unit. And cos of 60 degrees. So this will give you 5.4 into 10 to the power minus 3 Weber. Understood, everyone? All right. Next question. The magnetic flux threading a coil, threading a coil, threading means passing by. Threading a coil changes from 12 into 10 to the power minus 3 Weber to 6 into 10 to the power minus 3 Weber in 0.01 seconds. So you have to calculate the induced EMF. Calculate induced EMF. Calculate the induced EMF. Do it.
Zero point 0.6.
Pardon?
So the answer is 0.6.
0.6 volts. Very good. It is 0.6 volts. Anybody else with the same answer? This is correct. No one? See, EMF is nothing but phi 2 minus phi 1 upon t, change in time. So if you put this values, phi 2 is this, phi 1 is this, and there will be a negative sign outside. Because according to Lenz's law, the change will be opposite to what EMF has been produced. So EMF always opposes the change. Okay. So from there you'll be getting the value 0.6. All right. Next question. Let us move on to the motional EMF conditions. Fleming right hand rule. So according to that, let us first solve a question from NCERT. The NCERT question says that an aircraft with a wingspan of 40 meters flies with a speed of 1080 kilometer per hour. Okay, in the eastward direction. In eastward direction, right? At constant altitude in the northern hemisphere. In northern hemisphere. Okay. The vertical component of Earth's magnetic field is given, and that is 1.75 into 10 raised to the power minus 5 Tesla. You have to find the EMF developed. Find the EMF developed between the tips of the wings. Developed between tips of the wings. Tips of the wings. Do this. Done? Anybody? It's easy. Can I solve it? Okay, see here. So basically, let us say that this is our plane and these are the wings. It is flying in the northern hemisphere. Okay. And the vertical component of the Earth's magnetic field are going down like this. Vertical component are going down. So magnetic field downwards, velocity is rightwards. Okay, and the length of the conductor where the current will be flowing is in this direction. So BLV, that is the EMF, and all of them should be perpendicular to each other, and they are, isn't it? So EMF will be equals to BLV, right? Magnetic field, how much is the magnetic field generated? That is the vertical component of magnetic field. If they would have given you the magnetic field, so you will have to calculate the vertical component by taking the cos of angle theta or sine of angle theta, depending on what is given. B into length, length is 40 meters apart, and velocity you have to convert into meters per second. So 1080 kilometer per hour into 5 upon 18, that will give you 300 meter per second into 300. This will give you 0.21 volts. Did you understand it, everyone? Laya, Darshini, Namrata, Netra, Ditya, everyone, tell me, do you understand it? Or shall I explain it again?
Yes, sir.
Got it, sir.
Yes, sir.
Got it. Good. Okay. Let us move on to the next question. A jet plane, a jet plane is traveling west. Is traveling west at 450 west at 450 meter per second. 450 meter per second. Okay. If horizontal component of Earth's magnetic field, if horizontal component of Earth's magnetic field at that place, is 4 into 10 to the power minus 4 Tesla, and angle of tip is 30 degree. Find the EMF. You have to find the EMF induced. Find the EMF induced between the ends. Same question, between the ends of the wings. Let us solve this. Ends of the wings having span of 30 meter. Having span of 30 meter. Let us solve this. Anybody up with the answer? This one is easy. Okay, see, I'm solving it. We have been given the magnetic field. Okay, as I told you, we require in such conditions. Again, we have a jet plane here. Jet plane will be something like this, and we need the vertical component of the Earth's magnetic field. But we have been given the magnetic field. So magnetic field, what is the like vertical component of Earth's magnetic? Okay, one more thing. We have been given the horizontal component of Earth's magnetic field. So this is the magnetic field. This is magnetic field. This is horizontal component, and this is the vertical component. Okay. So this is delta, angle of dip. Angle of dip is always the angle between magnetic field in the horizontal component. So tan delta will be what? BV upon BH. We need BV. BV will be BH tan delta. All right. So BH tan delta. EMF will be what? BVLV. BV is what? BH tan delta into length into velocity. Okay. So BH is 4 into 10 to the power minus 4. Tan of delta is angle of dip is 30 degrees. Okay. And length 30 meters, velocity 450. If you solve this, you'll be getting 3.12 volts. Everybody got it? Yes or no? Everyone got it or not?
Yes, sir.
All right. Last question for today. Last question. Let us get to the topic of station. Okay. A circular coil of area 300 centimeters square and 25 turns. 25 turns rotates about its vertical diameter with an angular speed of 40 per second with an angular speed of 40 per second in magnetic field, in horizontal magnetic field, okay, of magnitude 0.05 Tesla. What you have to do? You have to obtain maximum voltage, obtain the maximum voltage induced in the coil. Obtain the maximum voltage induced in the coil. Do this. Anybody up with the answers? All right. Any answers? Shall I solve it? Okay, see here. So E naught is NBA omega. Okay. But the basic thing is E is NBA omega sine omega t or cos omega t if you differentiate it accordingly. So maximum value of this angle is 1. Okay. So that's how you do it. So in order to get it maximum value, you need to get omega t as 90 degrees and in other case it is 0 degrees in cos if it is there. So this will be 1. So this is your E naught, maximum value. So maximum value, just need to put the values. That is 25 turns, magnetic field is 0.05, area is given 300 centimeter square, so 10 to the power minus 4, and omega is given 40 second inverse. So if you solve this, you'll get the value of 1.5 volts. Understood, everyone? Got it or not?
Yes, sir.
All right.
Yes, sir.
So that was all for today. But this is not all of the questions. You need to practice more. Do we have this maths class after half an hour, I guess?
No, sir.
No. All right. I think then somebody else's class is there. Okay. So we'll be doing it. Solve more questions, get yourself doubts, and clear it. All right. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.